Welcome to our classroom again. Today our topic is application of determinant. Basically there are mainly two applications of determinant. One is finding the area of a triangle and the second one is finding the root of the three simultaneous equations. Now how to find the area of a triangle? To find the area of the triangle joining the points A x1 y1, b x2 y2 and c x3 y3. All of you know that the area of the triangle joining these 3 points is equal to half into modulus of x1 into y2 minus y3 plus x2 into y3 minus y1 plus x3 into y1 minus y2 square units. Now, how to find this area using determinant? Using determinant, this area is equal to half into determinant of x1 y1 1, x2 y2 1, x3 y3 1 square unit. That is, when 3 points will be given, what you will do? You will write the coordinates here, x1 y1 1, the second coordinate x2 y2 here, and the third coordinate x3 and y3 here. Then you will get the area of the triangle. Now, how to show these points are collinear? Suppose this is point A, this is B, this is point C. Now, how to show that these 3 points are collinear? These points will be collinear when this area, that is area of triangle ABC, will be equal to 0. That is half into x1 y1 1, x2 y2 1, x3 y3 1 equal to 0. That is x1 y1 1, x2 y2 1, x3 y3 1 equal to 0. So, what you will do? You will find the determinant x1 y1 1 y1, x2 y2 1 and x3 y3 1. If determinant becomes 0, then the points will be collinear. Okay. The second application of determinant is Cramer's rule. What is Cramer's rule? Cramer's rule is a method of solving simultaneous linear equations in 2 or more unknowns by the use of determinants. Suppose there are 3 simultaneous equations, a1x plus b1y plus c1z equal to k1, a2x plus b2y plus c2z equal to k2, and a3x plus b3y plus c3z equal to k3. You have to solve x, y and z from these equations using Cramer's rule. So what you will have to do? First of all, you will have to write a determinant d, which you will get from the coefficients of the equations. That is a1, b1, c1, a2, b2, c2 and a3, b3, c3. a2, b2, c2 and a3, b3, c3. This is d. Now you have to find dx. What is dx? To find dx, you have to replace the column involving x by k1, k2 and k3. That is, you have to replace the first column by k1, k2, k3. All the other elements will remain same. Secondly, in the same way, you have to find dy. Now, what you will do? Replace the column of y, that is b1, b2, b3 by this k1, k2 and k3. C1, C2, C3 and here K1, K2, K3. Similarly, we will get dz as, here you will get K1, K2, K3 and here A1, A2, A3, B1, B2, B3. Now, how to find the value of x, y and z? X is equal to dx by d, y is equal to dy by d and z is equal to dz by d. So, we get the value of x as dx by d, y equal to dy by d and z equal to dz by d. Now, these three equations 1, 2 and 3 will have unique solution when d not equal to 0. In this case, we will say that the system is consistent. Now, when d equal to 0 and all dx, dy and dz equal to 0, the system will have infinitely many solutions, infinite number of solutions. The system will have infinite number of solutions. And one more case may arise when d equal to 0 and at least one of dx, dy or dz is non-zero. Then what will happen? Then the system will have no solutions. In this case, we will say that the system is inconsistent. So, we can make this table. When d not equal to 0, the solution is unique and the system is consistent. When d equal to 0 and dx, dy, dz all are 0, then there are infinite number of solutions and the system is consistent. And the third option is when d equal to 0 and at least one of dx, dy or dz is non-zero, then there is no solution and the system is inconsistent. Okay, now I am showing one example of Cramer's rule. Look, there is a system of linear simultaneous equation of x, y and z. You have to find the value of x, y and z from this system using Cramer's rule. What you will do, you will rewrite the equations as 2x plus 0y minus 1z equal to 1, 2x plus 4y minus 1z equal to 1, x, that is 1x minus 8y minus 3z equal to minus 2. Now you will have to write d equal to 2, 2, 1, 0, 4 minus 8, minus 1 minus 1 minus 3 equal to 2 into minus 12 minus 8 plus 0 minus 1 into minus 16 minus 4, that is equal to 2 into minus 20 minus 1 into minus 20, that is minus 40 plus 20 equal to minus 20. Okay. Now we are finding the value of dx. Dx equal to, here you have to replace the column of x by this constant column, that is 1 1 minus 2. Now 0 4 minus 8 and minus 1 minus 1 minus 3. Similarly simplifying, you will get here minus 20. Now dy. dy equal to 2 2 1 2 2 1. Replace the column of y by 1 1 minus 2 1 1 minus 2 and minus 1 minus 1 minus 3. We have to simplify this value, and dz equal to, you have to replace this column, so 1 1 minus 2 0 4 minus 8 and 2 2 1. Simplifying, here you will get the value as 0 and here you will get minus 20. Okay. Now you have to find the value of x, y and z. You know that x is equal to dx by d, equal to dx is equal to minus 20 by minus 20, that is 1. Y equal to dy by d, that is equal to dy is equal to 0, 0 by minus 20 equal to 0, and d, that is z, z equal to dz by d, that is equal to minus 20 by minus 20 equal to 1. Okay. Now there is one more example, that is find the area of a triangle joining the points m into m plus 1, comma m plus 1, m plus 1, m plus 2, comma m plus 2 and m plus 2 into m plus 3, comma m plus 3. We will do the sum using determinant. Now from determinant, we know that area of the triangle joining the points x1 y1, x2 y2 and x3 y3 is equal to half into x1 y1 1, x2 y2 1, x3 y3 1. So here we will put the value. x1 is m into m plus 1, m plus 1, 1, x2 that is m plus 1 into m plus 2, m plus 2, 1, m plus 2, m plus 3, m plus 3, 1. Okay. Now we are just multiplying the elements, so that is m square plus m square plus 3m plus 2 m square plus 5m plus 6 m plus 1 m plus 2 m plus 3 1 1 1. Now what we will do, we will subtract row 2 and row 3 from row 1. That is, we will do R2 dash equal to R2 minus R1 and R3 dash equal to R3 minus R1. That is, we will keep R1 fixed. M square plus m plus 1 1. R2 dash R2 minus R1, this minus this, that is 2m plus 2. 2m plus 2, here 1, here 0, this minus this, that is 4m plus 6. 4m plus 6, this minus this 2, and now if we expand this determinant through third column, we will get 1 into this into this, that is 4m plus 4 minus 4m minus 6, half into minus 6, that is minus 2, that is minus 1. Now look here, we are getting an area which is equal to minus 1. We know that area is always positive. So what we will have to do, we will have to take the modulus value of this determinant. That is, we have to take its modulus value. Mod of this. So this is equal to 1 square